Most companies have an existing portfolio of applications, databases, and server infrastructure that's been growing over the years. Cloud services have caused an explosion of even more resources created in silos across data centers and various cloud providers. Edge scenarios are poised to create an even bigger sprawl. Azure has customer resources running around the world. Hundreds of millions of Azure resources are organized, governed, and secured daily by customers using Azure Management. Customers have asked us how to bring Azure Management to all their entire IT estate. Azure Arc extends Azure's control plane to manage servers and Kubernetes clusters across on-premises, multi-cloud, and edge. This empowers operators to organize, secure, and govern resources anywhere, and developers to safely deploy their applications and Azure data services to any infrastructure. Azure Arc makes it easy to adopt cloud practices on-premises and other clouds, all with central IT guidance and governance from Azure. Welcome to Azure Arc.
Hey, it's Jay. Welcome back to AzureFunBytes. What do we do every week? We get together, we have a conversation about all the different fundamentals, the services, the products that make up an amazing Azure experience. Last week, we got together with Donovan Brown. He really helped us out with understanding more about using Kubernetes with Helm. And we talked a little bit about his journey through that. And so it was really interesting. If you haven't watched it yet, head over to the YouTube channel. You can check out the previous episodes. I think you'll get a lot out of it. And always remember that you can send questions to me on Twitter at @JDestro. It's right there. There we are. But I want to make sure that we bring in my guest, who I really am thankful is part of this. And so here he is, Brendan Burns. How are you today, Brendan?
I'm doing great. Thanks, Jay. Thanks for having me.
My pleasure. Thanks a lot for being part of this. I think that it's rare to get that high up in the org chart sometimes, and you were really willing to kind of come and be part of this. And so I really appreciate that. Your time, I know, is extremely valuable.
Oh well, it's no problem at all. I'm happy to do it.
Great. So I know we've got some interesting things to cover today around Kubernetes, containers, Azure Arc. We did the preview for before, and we'll talk a little bit about that. But before we get into the big stuff, I want to remind everybody, as always, you have a poll to take. That's right. We want to know a little bit more about what you're doing and how you're doing it. And every week we put up a poll. And this week we want to know, are you using Kubernetes to deploy your apps to the cloud? Pretty simple question, yes or no, let us know. But sometimes it's complicated. So I always give that option. It's always one of my more fun options to choose. And so we've got that. And I want everyone to know, if you have questions today, please hit the chat. Let us know what you're curious about. We want to hear about it. We want you to be part of this. So now that I've kind of got through my spiel, Brendan, I'm going to ask you a few questions. And the first one is, I know you have been in software development for a while, but how'd you wind up here doing what you're doing now?
Sure. Yeah. Getting longer every day. So I started. My undergraduate. I graduated in 1998 with a degree in computer science and studio art. Actually, a double major in studio art and computer science. I went. I was going to school in the Northeast, and most of my friends were headed to Boston. So I went and lived in Boston and worked in the software industry in sort of the early days of everything becoming dynamic web. So, this was in we were reading the specs for what was to become like Java server pages and what was to become EJB, and, figuring out how do you transition from static web serving to, where people just sort of put, here's my menu, here's my, store or whatever, up to I can actually maybe take an order. I can actually, do something dynamic on the web. And the tech, the tech was primitive at best. And I spent a couple of years doing that, and it was interesting. But I had kind of always wanted to go be a professor. And so I went back to UMass Amherst and I got my PhD at UMass Amherst, and I got a PhD in robotics, actually. So I spent about 6 years doing robotics. And one of the great things, actually, though, about UMass was that it forced you to do, well, forced you, it, as one of the requirements was that you do a synthesis project. And the synthesis project basically was to take two different disciplines of computer science and bring them together in some way, right? So what I did was did a project that was looking at how you could integrate robotics and network providing. So, like, could you use, if you had buses or lawnmowers or other kinds of things moving around an environment, or think about aerial drones moving over a battlefield, could you actually use that to provide networking to people? And so it integrated systems and networking and robotics, and it was sort of got me exposed to some of the systems faculty. And so I started doing a little bit more. I didn't, the PhD was still, at that point it was so far down the road that, and I really liked robotics, so continued on with that, but also continued to work with people who are doing more sort of operating system stuff, more programming languages style stuff, and, get a sense for what, went to like things like USNIX as a conference instead of just going to the robotics conferences that I'd been going to. I think that sort of set the stage for later stuff.
So you went out to Seattle, you came to Google, and I think that was around 2008.
Yeah. So I was a professor for a couple of years. I was a professor in Schenectady, New York for a couple of years at a place called Union College. And then, I think the thing about being a professor is you kind of can't choose where you live.
Sure.
And then you go where the job is, effectively. And I grew up in the Seattle area, and my wife and I were starting a family and that sort of stuff. It just made sense to come back to Seattle. So I went to work for Google. I got pulled onto a web search infrastructure team that was focused on low latency indexing. So stuff from news, stuff from Twitter, as sort of social media became a thing in sort of 2008, 2010. Worked a lot on social media search, private search. Learned a lot about applied distributed systems, what it's like to really run something that billions of people use every day. And I think that also influenced later stuff, right? And then, as big corporations do, big corporations have reorgs, and my project got moved to Mountain View, and I wanted to stay in Seattle, and cloud was growing and looked like a sort of interesting place, and I'd always had this interest in systems and infrastructure, and so I went over there, and about the same time, but it was interesting, actually, because like you suddenly realize, you step into a world that I hadn't been living for a while, and you step in and people are using Puppet and Chef and like these tools that had a lot of reliability challenges, right? You run a script on 100 VMs and it comes up 85% of the time or whatever, and people are manipulating them manually and logging in and stuff like that, and you're really seeing the pain of managing internet scale stuff in 2010ish is pretty bad, right?
I got to agree. I was working in a managed hosting company, and I remember so much how scale was always, I think, the biggest conundrum. You can talk about, all the networking requirements, security, but when you start having something blow up, whether it's a store or a website, I think we all started seeing what we would call the Slashdot effects happen more and more. And for those of you who don't know, Slashdot's a website, slashdot.org, and every single time something interesting got posted there, that website would break.
Yeah.
And so now, go ahead.
No, go please.
Oh, I was going to say, so now we get a little bit forward to 2013.
Yep.
And so 2013 is when I think the world kind of changes for people who are in any type of, cloud-based hosting, because Docker becomes a thing. So was your experience with Docker mainly just as a user? Were you doing development against it? What was your real start there?
Yeah, I mean, well, we were looking at I mean, so we'd been deploying containers for a long time. And we were thinking a lot about sort of like, how do we bring these sort of more modern cloud native models forward? But the first thing was like, you had to get everybody into containers, right? Like Netflix was talking a lot about immutable infrastructure, but they were building these VM images. And so like, we were like, well, how do we get people into, how do we get people to understand how you can do this immutable infrastructure, but have it be lightweight, have it be developer centric instead of being kind of more ops centric. And like right about at that time, Doc Cloud, which became eventually Docker, but Doc Cloud released Docker. And I think the first version of Docker I saw was 0.3. And we just started playing around with it. And, I had a couple different interesting experiences with it. One was like, it was very clear that this was going to be transformative. I mean, it was a really great packaging, really great user experience. But it was also really clear that nobody really knew how to use it. Right. So like, I remember kind of late in the game at some level going to a Docker meetup in November of 2013 in Seattle. And maybe it was 2012. Can't remember. It's a long time ago. And like, what was fascinating to me was like, there's all these people who are deeply interested in this thing. They could see that it was important in some way, but they just didn't really understand what it was or what it was doing. And I looked at it and I was like, this is the atomic building block. Like, this is the thing that then is the Lego that we use to build the giant, Death Star Lego or whatever. Death Star is not the right word. And so it was this amazing sense of like, wow, there's this transformation and we're on the crest. I don't know if you're surfed or anything, but like you feel that moment when you catch the top of the wave and like the acceleration is starting, but you're not actually riding it yet. And you just know it's going to carry you. And I think that was the experience that led to this, like, oh, okay, now we have to go do this thing. And then it became this with Joe and Craig and I, this very tactical discussion of like, how do we actually do it? Right. Like, it's one thing to know that this wave is going to go, but like, the truth is most of the time the wave throws you and you catch the tip of your board and you go ahead, and somebody else goes by you looking awesome. I think that became the sort of obsession, was like, not just what do we need to do, but actually how do you turn it into a movement? How do you turn it into a community?
So eventually yourself, Joe Beta, Craig McCluckey, you start working on this project that now I'll be frankly honest, it seems like it's something that's kind of taken over the world when it comes to distributed computing. And that's the birth of Kubernetes. I remember, just being someone in this industry, hearing about Borg and hearing about the different ways that containerization was starting to really become more common in Google. And I think that, it was kind of leading the charge. How did the idea that, let's have this thing that grabs YAML and starts creating your infrastructure, how did you really get to that point?
Well, I mean, I think it's important to realize that, like, at some level, these ideas had been percolating around for a long time, right? Like even in my undergrad days, remember running this software called Condor that was done by, I think, University of Wisconsin, where you kind of like gave it a tarball and it would move the tarball around to find different idols, called Condor, Hunter of Idle Workstations. And it would like move your job around. It's very, very batchy, but it would move your job around to kind of like try and find places where you could run the compute. So like, I think there's, I think because it sort of did this hockey stick thing, there's this sense that like, it was this brand new tech that, and it's really not. It's like, maybe, I guess, much as Docker. I mean, I think when you look at Docker, they didn't build anything new, but they packaged everything. Yeah. But they packaged everything in a user consumable way, and they made it clear to people why they should care.
Yeah, that API really changed everything. The idea that like, all right, here's a way to use this technology, and let's simplify it a little bit. Let's go ahead and say, containers are not just something that you're using in production. You can use them locally for things like development. And that was really my first big foray into using containers, as I was working at DigitalOcean at the time. And, we had to do builds of different stuff with Ruby. We were doing stuff with Chef. We were building all this stuff, and we needed test environments. And so just using Docker became something that was almost secondhand, because containers just made everything so much, simpler. If it worked on my computer, it'll work in the cloud.
Yeah. And I think drawing a connection back, I think that was one of the advantages of having actually gone out and taught for a while, was that I think some of the hardcore systems people had a really hard time separating their understanding of what this thing was doing from what was a useful thing that was easy to use and where it would make a lot of people, want to use it, right? And I think a lot of times when you're teaching, you're not so much focused on you're focused on trying to help people understand less than the details of the tech, right? There's just this difference of the serious hardcore practitioner and the person who is trying to bring people along. And I think that perspective really helped, in a lot of places, because we would, people would say, well, when are you going to get to, because the very first version of Kubernetes supported 100 machines, right? Maximum 100 machines. And even then it was a little sketchy at 100 machines. And Mesos at the time was we do 10,000 and, what is a toy and all this sort of thing. And there were some people who were really hardcore systems people who were it really hurt. They were these guys in Mesos are calling me out and they're telling me my engineering's not good. And I'd have to be guys, focus on the user experience. We have to nail the first 2 hours. And if we nail the first 2 hours, we know we can scale this thing. We know we can get there. But if you don't get people in the door, who the hell cares if you can scale it, right? And
I think that goes for almost any real business as well. If you create a user experience that people are finding something, welcoming, and take away a lot of the friction that comes with almost any kind of acquisition of new software or just deployment of new methodologies. Even when it came to things like Chef and Puppet, it took away that whole idea of I'm going to have to sit down and I'm going to have to write my own scripts and really put the effort in, and to see that there are APIs that can just kind of take some sort of inbound instruction. It I think really brought us to a place where we weren't just looking to people in ops to make sure that what we build got online. And I think that that's a big kind of divergent part of the industry, and how things kind of started to move in the direction where the developer became more and more empowered to be the person that deploys.
Yeah. I think Kubernetes is absolutely a culmination, and Docker too, for that matter. I don't think Docker can happen in 2008, right? I don't think Docker could happen in a time, you kind of had to have DevOps, and you had to have people go through the CI/CD thing, and you had to go through a lot of these, you had to convince people of a lot of problems that needed to be solved before Docker becomes an obvious solution to problems that they have, right? Sure. And I think, so they were all a product of our time. And I think Kubernetes is the next step, because Kubernetes kind of said hey, you did all that DevOps stuff and it was great, but you were still kicking out these primitives and dealing with these cloud APIs that were kind of archaic, right? They weren't developer oriented, right? The cloud APIs of the time, where it's a VM and a disk and a network interface car, it's all just a virtual analog of a physical thing that the ops person was going to give you. Right. And I think one of the most important things that Kubernetes did, and we talked a lot about, was that we were application-oriented infrastructure instead of being systems-oriented infrastructure. We're still infrastructure as a service. We're still going to provide infrastructure primitives, but they're going to be the primitives that a developer wants to think about. Right. A developer doesn't think about a network interface car. They don't think about, a virtual machine. They think about, hey, I have this program and I happen to have packaged it up as a container, and it needs 4 cores and 10 gigabyte RAM. It doesn't say, oh, I'm a DSV3 VM with 2 interface cards and living in this virtual subnet. That's just not what a developer thinks about.
Sure, and then the runtime environment gets involved in the next. And I think that having specific runtime environments, whether you're coming in and you have Node, or Go or something in the background that you can just say, I'm always going to get this repeatable, reliable process to eventually my code is going to get, baked into this image and put up into a container. I think that also just the standardization around runtimes being, so stripped down from the operating system side and just saying, these are the things you need.
Yeah, for sure. And then I think the other thing is that we also, though, wanted to help carry people forward. So I think we also added some stuff, right? Like we said, hey, containers can have its own IP address, right? Like that was probably the most controversial thing we did early on. And then also just things like health checks, where it was like, okay, like literally you can just give us a little URL and we'll just take care of the rest of it for you. Like you knew you had to, it's kind of like unit tests. I mean, I always said, like, in a world where, unit tests are really, really hard to write, it's hard to get somebody to write unit tests. But
Sure.
Once there's like JUnit or whatever, like it's pretty hard for a developer to be like, no, I'm not going to add a unit test to this unit test framework that you already have. Like, it's just not easy. And then same thing's true with health checks, right? Like if you had to invent your own health system and your own restart and all that sort of thing, you can understand why someone's like, well, it's maybe not worth it. But when literally it's like, add these 3 lines of YAML, it becomes very hard for someone to not do the right thing, So I think figuring out also how you design it so that people fall into that sort of pit of success is a big part of it also.
Yeah, you give people the tools, essentially. Yeah. You tell them, go build, the greatest ship you can, take off and be the Enterprise or whatever it is you want to be. Build that big starship that's going to get you to the next big place that you can go to. And I think that's some of the things I saw with originally Docker, and then Kubernetes, which now is 6 years old. It's on version like 1.2.1 or something like that, or 1.2.0.
Yeah.
And so there have been all these advancements to your baby, and I know we're going to talk a little bit about them. But what's the thing, and before we start getting into the big meat of today and some of the stuff you want to show you, what's the thing that you're most proud of that's happened since this whole kind of project exploded into what it's become?
Well, I mean, I think it's really important to note that, like, from the beginning, it's been a community effort and it's been a group effort, and it was set up to be a group effort, right? Like I'm sort of constitutionally allergic to the notion of like the benevolent dictator for life open source project. I mean, with all credit to Guido and all that sort of stuff. But so I guess, I mean, and that I guess dovetails with the thing that I think I'm most proud of, and I think we should be most proud of, which is that community. Like, I think truly built something there that's exceptional. Frustrating at times, horribly frustrating at times, and but unique and way better than anything else. And I hope that it'll serve as a model for things to come. I think there's been lots of successful open source projects and lots of interesting technology that people have built over the years. And so, like, none of that Kubernetes has done is particularly differentiated, but I think that the community is differentiated, right? And maybe it just means that it's open source for the for the next generation or something like that. I mean, I think one of the interesting realizations, I'm an old person, but one of the interesting, and I'm not on very much social media, but like one of the interesting things that Brian Cantrell said to me once was, GitHub is like Instagram. Like, GitHub is Instagram for a certain segment of the population, right? It is social media. And I think the Kubernetes community maybe kind of reflects a little bit of that.
Sure.
It's a little bit more of a modern community than the other big communities that have come before, some of the Apache communities or other things like that. Not to say anything bad about any of them, but it's just a little bit different. It's a GitHub community. It's maybe the first really big GitHub community.
Yeah, I think that what people have done with GitHub individual repos and the idea that this project, lives here and it's up to people to help evangelize what has been worked on, what people are doing. And so that's been, I think, a big part of what the community has done, is evangelized exactly why this makes sense for you, for your distributed systems, eventually talking more and more about microservices, integration with, on-prem and cloud environments, all these things. I just knowing that community has such a big commitment to seeing the product or the project rather, because I prefer to call it as a project. Things that use it are products. Yeah. I think seeing the advancement of the project and how people have really, I don't know, I would say have an emotional connection to it in some way, because they've seen how much, if you're part of the process, how it will help other people.
Yeah. No, I think it's true. And I will say that, like, I mean, I was I sort of cut my teeth in the FreeBSD Linux wars of the late 90s, early 2000s, and when that was a thing. I mean, it's kind of amazing.
FreeBSD jails forever.
Yeah, well, but I mean, so it was a real thing, and it was pretty nasty at times. And I think the lesson that I took away from that was that you can be as good as you want technically, but if you're a jerk, your system's just not going to win. I think my perspective about the time is that FreeBSD was better. It was more secure, right? But they were just kind of jerks. And so, it's if you build a bigger tent, you're just going to win, and the stuff will get fixed. Sort of like the scale thing earlier. It's like, if you get enough people interested, somebody's going to come along and fix your scale problems. But if you don't get anybody to join you, it's pretty hard to win globally with a team of 10 people.
Yeah, that makes a ton of sense. And so I want everybody, before we're going to get into some of the more interesting bits of exactly what you're working on lately and what you're interested to show us off today. But I want to remind everybody of a few things. One, we talked about it before. I'd love you to take the poll. Go ahead, head to aka.ms/LearnTV. If you're watching on one of the other channels, head over to the LearnTV page and answer the poll. The other thing I want you to know is that there is an Introduction to AKS, Azure Kubernetes Service, Learn module. I think that it's really, really good. It's got you a sandbox to do work in, to be able to get that education and do the things you want. And the other big thing I want to remind you of is Microsoft Build. And Brendan and I talked about this just for a second. I know he's got some stuff planned for Build. I think a lot of us in Microsoft, we've got something planned, whether we're going to show up and watch or be part of it. But make sure you head over to the Build registration site. So Brendan, I know you talked to me yesterday or whatever it was, the day before. I forgot.
Yesterday. It was yesterday. Hard to remember.
Yeah. Time is
a lot of stuff going on.
Yeah. And you told me one of the things you really wanted to talk about was the VSCode integration of Kubernetes, specifically Azure Kubernetes Service. And so I hope that maybe you want to give us a little more detail, show us a little bit more about that. I'm going to bring up your screen. All right.
Sure. Yeah. So, I mean, I think one of the reasons why I think this is something that I'm so interested in is because, we're starting to hit this point where the bulk of people who are using Kubernetes may not be people who are in that GitHub community that we were talking about earlier. They're people who are, honestly just there to get their job done, right? And I think that one of the greatest things that is in the cultural DNA of Microsoft is effectively empowering that developer productivity, empowering people to get their job done. And one of the ways we do that is the tools that we build. And that's where, the Kubernetes extension for VSCode comes in. I actually wrote the original one. Maybe the reason I like to show it is because actually, the original code was mostly me, although the team has taken it over since then. But the real idea behind it was there's a lot of great tools out there that the Kubernetes community has built, but they're not necessarily familiar. If you want to learn the ways to do things with kube control, you can. But it takes a long time. It reminds me sort of when I used Emacs, and you talk to another Emacs user and they had a completely different set of key combinations than you did, almost a perfect disjoint set. And because there's just so many different options and so many different flags and so many different ways of using it. And I think what we did with the VS Code extension is really distill a bunch of those experiences down into a more familiar context. And so to give you an illustration of this is a Kubernetes cluster. It's in my, right click is no good. This is actually my home cluster that's running down in my basement. But But if I take a look at the workloads and I take a look at the deployments, I can actually see a bunch of the deployments that I have running. And so, for example, I have this security camera that is running in my house. And I can actually go and say, okay, let me take a look at that pod. And now I've seen the pod that's part of this deployment. And that's all very natural. Like, I mean, we've had 20 years or 30 years or however long of like tree views and diving down to the floor. And so like, I didn't have to teach anybody any different commands about how to do anything. Like, it's just natural, right? And then similarly, we've had a long line, of people training us effectively that if you right click on something interesting happens. And so if we right click, oh, that's not right. If we, let's see if I can, I don't have my 3-button mouse here, so I have to remember how to do this on a single trackpad. There we go. So if I right click, what I get is a context menu for that pod. And in particular, I can do things like say, hey, I'd like to take a look at the logs. And now actually, that zoom in is not beautiful, but I'll maybe do this.
There you go. That's not so bad right there.
That's better. So like now you can actually see that by integrating the logs into this container, I chose a bad container. Actually, this container doesn't have a lot of logs. But I can actually start doing interesting things with the GUI where I can slice through it. I can search. I can, take a look and find different things. And, effectively, the great thing about being in a development environment is as I'm looking at those logs, I can also be in the source code that's emitting those logs, right? And so I have that level of integration is really valuable when you're trying to figure out why something went wrong. But similarly, I mean, it goes beyond. Let me go back over here. It goes beyond just like looking at logs for a container. I think one of the other things you'll see here is I have a terminal. I can actually go there and it's actually going to give me a terminal. So now it looks the same, but I'm actually inside the pod, inside the computer that's running in my basement, and actually can go in and do whatever I need to do inside that terminal. So again, like you could do this through kube control. Yeah, there's nothing that does, but you have to remember, the pod name. You have to remember the namespace. You have to remember I need to add -it to make it an interactive TTY terminal, right? Like there's a lot of just sort of cognitive overload, for lack of a better term, that you're forced to take on, and just stuff to learn, frankly, that you're forced to take on. That having it integrated into this familiar environment just fixes for you, right? And I think the last piece of that is also, it has a security value because like we can actually go through here and we can say, actually, I want to port forward. And I can just say 8080, 8080. Because, I think one of the things we see a lot is people accidentally putting things out on the internet. And now there's a port forward going from that pod to my local host. I can just access it from a web browser on localhost. We see tons of people run into security problems with accidentally putting things out on the public internet. And usually it's just because they want to interact with it. Right. And the easiest way for them to interact with it was to put it out on the public internet. And they didn't think, hey, every single public IP gets scanned by some, system out there that's dialing, looking for interesting stuff. I mean, I just saw an article that, some security team had found, something like 20,000 unsecured Kubernetes clusters out in the wild. Right. Just like,
I like to think about this. This is like a huge story, the crypto jacking. Over at Tesla and what happened there. The idea that, the basic security that we assume would happen, whether it's port forwarding, whether it's putting some sort of authentication in front, people don't always remember these things do happen. And so the fact that there are tools that are actually there helping you before that problem happens is really
useful. And I think it's more than just like helping you before the problem happens. I think that it's just about making it easy for you to do the right thing, right? Like people don't just go set out and say like, oh, I'm going to ignore all security stuff and put this. It's just like they're trying to get their job done, and they and there was actually another interesting blog from Microsoft actually recently about Kubeflow and people with unsecured Kubeflow installations, very similar to the Tesla incident. And again, it's just like. It's just people trying to get their job done and it just not being easy. And so I think if we make it easy, we inherently kind of make it secure because, people don't have to do weird stuff to that where they can mess up and put things on the public internet. I think that
there was that.
Sorry, go ahead.
I'm sorry. I was going to just say that there was that blog post that Yossi Weissman.
That's what I was talking about.
Yeah, back in June of last year was misconfigured Kubeflow workloads are a security risk, and you know I think that what it really comes down to is that people can port scan. You know what I mean? People still do this. There's still script kiddies out there. They're making your life hell.
Yeah.
And so making the right decisions beforehand when it comes to security is super important.
Yeah. And I think that brings us into, sort of another area outside of VSCode that I'm pretty excited about, which is the work that the team has done in Gatekeeper, which is the policy implementation for Kubernetes. So, it's great to have tools that sort of lead you down the right path. But another aspect of this is making sure that, the things that people create on the Kubernetes cluster, that they can't take the wrong path. So there's make sure people follow the happy path, and then also make sure people can't take the wrong path. And the Gatekeeper project that actually Azure started, but then donated to the CNCF under the policy framework that's already in the CNCF, and has now gotten sort of industry adoption, is the way that we're seeing, IT or DevSecOps or whoever you sort of plays that role in your company, ensure that not only, do we try and guide people down the path, but that it's impossible to not go off that path. And I think what's great about that also is I think it's a good story of how we think about open source and product together. So it started out as an open source project, and a community project donated to the CNCF. But of course, with something like policy, there's two bits of it. You want to do it at scale, and you want to do it through someone where you can get support if it goes wrong, right? And because it's just so mission critical, you don't want to be sort of I installed this open source thing, and hopefully it connects to the right MongoDB, and whatever. And so we took that Gatekeeper project and we integrated it back into AKS and integrated it with Azure Policy, so that instead of you having to handcraft policy, you can actually use built-in policies, right? So Azure has built-in policies that says, oh, okay, what is it? It's sort of more task-based, because the policy language for Gatekeeper is this language called Rego, which is great and it's very expressive, but it's hard, right? I mean, it's like any other language that you have to learn. It's hard to do the right thing. And so if you can instead, via the Azure portal or through the CLI, say, hey, no, this is the kind of thing I want to do. And Azure says, okay, here's the policy that you should use. You can click a button, fill in a few fields, and now you're blocking all container registries except for your private container registry. That's really valuable. And then also, because it's in the cloud, you can do it at scale, so that you can point all of your clusters to that single policy, and you don't have to maintain 50 different copies of a policy and hope that they stay in sync. And that also, I think, brings the other interesting part, which is we also took that same policy engine and policy framework and integrated it into Azure Arc, so that you can scale out policy to Kubernetes anywhere, right? And so the same rules that make sure you don't put things on the public internet in Azure can make sure you don't put things on the public internet from your data center.
That was just going to start asking you a little bit about Azure Arc and that new implementation. It's only, I think, a month old since it went GA.
Yeah.
So can you give me the big idea? I mean, I know Arc is about running Azure anywhere. What is the motivation behind using Arc with Kubernetes?
Yeah, I mean, I think that the motivation for Arc in general is this notion that, I think I'll start with the backstory, I guess. I think when I came to the cloud, I sort of had this mental model, and I think a lot of us had this mental model that the cloud was the future and people were going to move from their data centers into the cloud. And that was the trajectory. It's a very linear trajectory. It's data center bad, cloud good, we'll get there eventually. And I think the more time I've spent in the cloud, the more I've realized that while the cloud offers a tremendous amount of advantages, there's also some very legitimate reasons why certain workloads and certain applications are just never going to move. To give an example, we have a number of customers who are in shipping, and they're putting Kubernetes, on their boats, on the shipping boats, to do machine learning, to do inventory management. I actually just was listening to Marketplace, and they're talking about the number of containers that have been lost, like blown off ships, because now we're pandemic wise, we're shipping so much more stuff. Containers get blown off ships. There's record numbers of containers that are disappearing into the Pacific Ocean. The shipping people want to maintain, want to understand what's going on. How could we do a better job stacking? Where does the container come from that fell off and things like that? And they're using Kubernetes to do that. Obviously, like, you can't take that ship and put it in an Azure data center.
Yeah.
Right? And so there's this need to be able to have this compute anywhere. And I think there's also a recognition of the fact that those environments are going to be so heterogeneous and specialized that, something that is a sort of a heavy cloud, I guess I would say, sort of like we're going to take like Azure Stack, which is, let's take the Azure data center and miniaturize it and give it to you, is great for certain scenarios. But there's a broad customer base that, for a variety of reasons, is going to say, you know what, actually, I just want Kubernetes. I don't actually need the rest of the lower level bits of the stack. I want to start at Kubernetes and go up. And I think that's
just want to bring it closer and closer to the edge, if you will.
It's maybe they already bought a bunch of infrastructure 2 years ago, and they're on an amortization plan that says examples, things get qualified for different environments, for marine environments, for other kinds of environments. It's a 10-year investment to buy a set of computers to put on a ship or whatever it happens to be, right? And so I think there's a real need to be able to meet those customers wherever they are. They still have that need for centralized inventory. Like, just because your computers are on a ship doesn't mean you want to go to the ship to find out what computers are on the ship, right? Like, you want one dashboard to say, hey, I'm in compliance. Hey, I'm patched to the latest versions. Hey, let's make sure the policy is the same everywhere. Let me even just frankly understand where they all are.
And control planes. Sorry? Control planes, saying it ends up being one of the big things that people look toward so that they can automate processes. That's the big reason why people use AKS. There's a control plane. They're able to, have certain jobs that run that automatically do something to a cluster, that automatically, that are going through that Azure API that makes more sense to them than having to do it all from scratch, if you will.
And in many cases in the on-prem environments, there is no equivalent API. Right. And so Arc is about actually supplying that API for people to use in the on-prem environments, and enabling all that automation. Because I think the other thing that's happened is people have gotten used to the level of automation that they can do in the cloud, and bringing that level of automation to on-premise, sort of as we talked earlier with the tooling there on-premise kind of got stuck, I would say. Because I think in part because everybody was like, oh, well, it's this linear march to the cloud, right? And it's not, that's less clear. So Arc is kind of trying to bring a bunch of that cloud native orchestration, cloud native automation to the on-premise world as well. And consistency too, right? Like, if you're going to use an extension, I mean, even something like Arc for Server, where we can manage Windows Server or Linux machines on-prem, you can write a single policy for guest configuration and apply it. You don't have to care. And you don't care. You shouldn't care. Is that a VM running in Azure? Is that a VM running in VMware? Is that a physical server? At the end of the day, it's just a computer with an operating system that you want to push some configuration to, right? And being able to do that in a single gesture it's just a valuable time saver and also ensures better consistency.
Sure. And so that's one of the things, I just brought up. There's an article here from our docs, the quick start, how you can use an existing Kubernetes cluster and add that into Azure Arc. Have you seen that much lately? Have you seen people actually, taking that decision to, I guess, acquire Arc after the fact and make their clusters part of a bigger Azure solution?
Yeah, no, I think we're absolutely seeing both, right? Which is we see a number of people who are AKS customers who are looking at how do I go on-prem and I'm building a new edge platform and I'm going to use Kubernetes, and Arc is going to be part of the design from the get-go. But But we're also actually honestly seeing a lot of people actually who have maybe minimal Azure footprints, but who have a sprawling sort of on-premise estate and are realizing that they need to get their arms around, they're thinking about how they go to the cloud, but they need to get their arms around their on-premise state first. And they're actually using Arc. They're kind of Arc first. I think we see both AKS first customers and Arc first customers. And it's great to see, actually, because it means that, the value prop is there even for people who maybe haven't spent a ton of time in Azure already.
Sure. So we got about 15 minutes left. Sure. And so I was curious, was there anything around Arc you wanted to kind of show off?
I unfortunately actually don't have a great demo. My Kubernetes cluster in home, actually, that I was just showing you, is actually connected to Arc. I can actually just show you the, actually, I'll...
Because it's agent-based, if I'm right.
It is, yeah. So, here we go. Go drop over here. So if I switch namespaces, you can see in the namespace, there's this Azure Arc namespace. We can use that namespace instead. And what you see here actually is a bunch of the agents that are running. I can actually show you sort of a way that I used Arc. If I actually go over here to the RabbitMQ, I'll use this namespace. This RabbitMQ is being managed through Arc from a Helm operator. And so basically, what happens here is in the Arc console, I can go into the GitOps workflow for Arc, and I can say, hey, I want to deploy RabbitMQ to my home cluster. And the Helm operator then actually goes and uses the Helm chart for RabbitMQ, configures it, deploys it into the cluster, and actually keeps it there. And so if I come along and delete this, it'll actually bring it back. Right, and it'll show me the status in the Azure portal and that sort of thing. So I can actually, we can actually go into the. I realized I just shared VSCode. I didn't share my whole desktop, so I'm going to have to stop sharing. And
no problem.
You set this all up so that I wouldn't have to do this, but I'm going to do it anyway.
Hey, someone once said, when you do it live. This stuff happens. So I'm so used to it, and trust me, there have been far less elegant ways of showing people what it is they want to show. No worries. So I'll give you a second to bring that up.
There. Remember to sign into my personal account, not my work account. Didn't want to show you all the AKS production,
Yes. Can you give me a zoom, a +1 a little bit? Just so we can kind of see a little bit more.
Oh, sure. Yeah.
Thanks. There you go. Perfect.
So if I go over here, and here's my home cluster that is connected with Azure Arc. And if I go to the GitOps workflow, you can see here that this is the RabbitMQ one that is installed. And the last time it was updated, I installed it in February. It hasn't changed since. But if I click on that, you can actually see, I set it up here. I set it to point to a GitHub URL that has the Helm chart that I wanted to use. And it just takes care of installing it all for me. And so from this page, I can manage the applications that are installed onto this cluster that is in my basement through a GitHub repo. And actually, one of the other things you'll see here is I actually have an Azure function installed, which is one of the other cool parts about Arc, I think, which is that we're bringing a lot of the higher level developer experiences to Kubernetes at the edge also. And so this is using the Kata project that is out there on GitHub also to provide an Azure Functions experience, but running on a Kubernetes cluster. So you can use the same func tools that you're used to. You can use the same triggers and bindings that you're used to. But it's not running on Azure. It's actually just running locally, in my home cluster. So that's really nice also because it means that, we talked a lot earlier about the container and container build and that kind of stuff.
Recursion.
Yeah. We talk a lot about how you can build a container and deploy it, but the truth is that actually, for a lot of people, the building of the container is a bit of bit of a jump, right? It's a bit of a step. And, things like Azure Functions can actually make it very easy, much, much easier to take your code, get it into a container, and then the integration with Kubernetes just gets it out there, right? So I think we always are trying to figure out how do we get people productive as quick as possible.
Sure.
And that's part of it.
So there was a big announcement today, and I wanted to just get that out there and talk about that for a few minutes. I saw you put up a blog post, and Microsoft acquired Kinvolk to accelerate container optimized innovation. Do you want to talk a little bit about that new acquisition and what that means to AKS and Azure users?
Yeah, for sure. I mean, we're really, really excited. The Kinvolk team, because one of the great things about open source actually is that, you work with all these people already, right? And so we've done a lot of work with the Kinvolk folks in the past, from Vincent Batts, their CTO, and others. And they have a ton of just fantastic experience in both the Linux and Kubernetes communities, and not just sort of in like the running of the things, but actually in the innovation that's happening. And so I think that they're pushing the boundaries in things like eBPF inside the Linux kernel. They're pushing the boundaries in how you think about debugging and introspecting Kubernetes clusters. And they're also really, obviously, because they've been doing bare metal stuff, they have a good set of skills at the edge, and a good set of projects at the edge, with things like Metal LB, which is one of their projects, providing a load balancer solution for people who are running Kubernetes in physical hardware. So it's really awesome to get a chance to work with that team every single day instead of sort of every once in a while, and to I think also give them the opportunity to scale their innovation, right? I think that we're really excited about taking those ideas and sort of getting them out to the tens of thousands of people who use the Azure Kubernetes Service every single day. And that I think that's I hope anyway, that's one of the things that they're seeing in us as well, is that their reach and their opportunity for impact. I mentioned earlier like how cool it is to be able to know that your software is getting to billions of people. Like there's only a few public cloud providers in the world, and so there's a real opportunity to sort of accelerate and scale their impact.
Yeah, I know that, when it comes to building something and having people really find that value, it's what it all comes down to. And if you as a company can scale out the business, add more resources, you can add more value. I mean, most of the time we like to think about that happening that way. Yeah, but sure. I know that Microsoft has made a real commitment to Kubernetes. How important has the support been from, like, I guess, the corporate structure to getting you what you need done to make sure that the people you work with and alongside are able to deliver?
Yeah, I mean, I think it's really important. I think one of the things that makes obviously there's just the financial aspects of doing a deal, but I think more importantly, especially in the Kubernetes environment, it's competitive, and creating a place that people want to be at is part of it also, right? Like where people can be successful, right? Like I think so. It's a combination. In some ways, the resources to do an acquisition are the easy part. It's developing a place where a team like that can join, be happy, be successful, be productive, continue to work on the things that they are excited about. That's huge, and that requires a ton of support, right? That requires, in fact, a lot of the cultural change that people have been driving, that frankly Satya has been driving over the last few years through the company. I think it's also a factor of being, I've always said that having a public cloud is sort of the best business model for open source that there ever was. And so that's a big part of it also, that like hyper focus that Microsoft has on the cloud, and on scaling Linux in our cloud, and Kubernetes is a part of scaling Linux in our cloud. That's a huge thing. But even things like VSCode and GitHub, right? Like if people are already using every single day the tools that you produce, they kind of naturally have an affinity. They know that you can help them out in that context. I think it shows that we can provide a comfortable home in a variety of contexts. I'm very grateful to the level at which also people just will trust, right? The level at which people are willing to trust my judgment or trust other people's judgment. It's been fantastic.
And customers seem to believe in what resulting product it is from all this work. If I'm right, the last I recall, AKS is one of the fastest growing products and services that Azure has developed, and I think that in itself is a testament to the work that people like yourself and Gabe and Lockie and all the people inside Microsoft have done over the last few years of being able to not just build something, but to scale it, to make it always updated, to have all those different versions. And I think that's something that we don't kind of talk enough about. But the fact that there are everything from older iterations, because the semantic versioning that you have, you can go through and find a specific version. If you've got something that only works in that, and why that is, that's your decision to make, time to update. But the fact that you're having your team maintain so many different versions, which is deployed against so many different clusters, but then having ways of like automated upgrades. All these things, I think it's been very, very big, and it's really cool to watch it all kind of grow.
Yeah, I mean, I definitely want to shout out to the AKS team. I mean, they are, the engineers who are on call. I mean, even as we speak on call, the engineers who go do really deep engagement with our customers to understand, is it a platform issue? Is it a customer application issue? It can be really fuzzy to understand where the problems are. They show a level of customer obsession that I think, I hope is a model for how every service in Azure can operate. And it takes a lot of energy. It takes a lot of emotional energy. It takes a lot of waking up in the middle of the night energy. It takes a lot of, focus, and we would not grow without them. And similarly, like, it's not just the product team, but it's also the people out with our customers, the field folks out with our customers, the people who are, like shows like this, evangelizing. It's very much a team effort to get to where we are. I'd say we're also a product of our time, right? Kubernetes is a really hot area right now, and so the growth that we see, I think, is a reflection that we're building a quality product, and also a reflection of the level of customer interest in how they can get more agile, how they can get more operational efficiency, how they can empower their developer teams to do more. And we take that responsibility pretty seriously, right? Like, I mean, we absolutely want to continue to explore. I was just today actually talking to the one of the leaders who runs our data centers about how we can do even more in the innovation between Kubernetes and our data centers to improve efficiency for our customers and provide a bunch of different sort of SKUs that are cloud native, if you will. So we're really excited about what the future will bring. And of course, to get it done requires the work in the upstream open source communities too, right? Which is where, people like Lockie and others, like, we can't do it by ourselves. We have to go into these communities. We have to do it in collaboration. And our customers are looking for that too, right? Like, they want to see us present in those communities. And I'm grateful, frankly, that like our, business leadership and the company leadership are willing to view it that way, right? I think, if you look at least one of the other public clouds, they have a little bit of trouble donating work to open source. They can't quite make the connection between, I do something over here that helps everybody, but actually it helps my customers and helps me in the long run. And I'm really grateful that we're not in that position. We have the ability to see that there is this long-term value to doing this altruistic work in the open source communities.
Well, Brendan, we're just about out of time. And so I wanted to go ahead and give you a big thank you for spending an hour with me. I think I've learned a lot, and I know that you've contributed a lot to my viewers today. So I want to say thanks a lot. And I really hope that you'll see this continued success. And so thank you very much.
Absolutely. Thank you. It was great to be here.
Great. So, hey, everybody, we're going to give you the big old wave goodbye. It was good seeing you all. We'll catch you next week. I'm going to have Thomas Maurer. We're going to talk a little bit about hybrid cloud and Azure. So until then, I will see you next time. Thanks for watching Azure FunBytes.